D class. First, to find out what is the binary string for two numbers. I'm just mentioning 145. Randomly, I'm taking 575. Just to compile and run, find out binary string content. You can do either manually or within statements. Either manually or within statements. So find out what is the binary string format for two numbers. Manually, if you wanted, you can define. Define manually also, you'll get a procedure once again. These are the binary values for 145 and 575. 145 is the binary value. 575. I just to taken randomly two numbers. These are the binary values. Now, let us see one bitwise operator between these two. 145 bitwise OR, single pipe. Single pipe is a bitwise OR. Single pipe bitwise OR. Just to compile and run, find out the output, then manually we can calculate the same output. Bitwise OR, bitwise OR. Bitwise OR is a 703. Let us see how this 703 is coming. In bitwise OR, you have to do operation in the binary string. So here 145 and 575 both are having a unequal number of digits, unequal. You can keep adding left side zeros to make a equal. While adding zeros left side, there is no change in the meaning. While adding left side zeros, power values are not increasing and multiplication with zero. Right side zero adding is more significant. If you are adding right side zero, power values will change. If you are adding right side 1 0, that will occupy 2 power 0. Next one will be 2 power 1. Left side while adding zeros, There is no significance at all. To make a equal length, I just added left side zeros. To make a equal length, left side I added. Now, bitwise or vertically, you can check it out. Vertically, everybody, 0, 1. Vertically, first column 0, 1. 0 or 1 is a 1. 0 or 0 is a 0 vertically. 1 or 0 is a 1. 0 or 0 is a 0. 0 or 1. 1 or 1. 0 or 1. 0 or 1. 0 or 1. 1 or 1. R, bitwise R. Come on, guys. Vertically, if any one is a 1, result will be 1. Vertically, every column you can check it out. Vertically, every column you can check it out. 0 or 1, 0 or 0, 1 or 0, 0 or 0, 0 or 1, 1 or 1. Vertically, 0 or 1, 0 or 0, 1 or 0, 0 or 0, 0 or 1, 1 or 1, 0 or 1. Now find out what is the decimal value for this. You know already the procedure for finding out decimal value. Find out the decimal value for this result. You will be getting 703. Check it out, everybody. Let us see the next bitwise operator. Bitwise and 1 ampersand, 1 ampersand. Bitwise and. Between these two numbers, bitwise and ampersand, bitwise and. Bitwise and, bitwise and. Vertically, vertically if both are 1, then only 1. But vertically both should be 1. 0 and 1 is a 0. 0 and 0. 1 and 0. 0 and 0. 0 and 1. 1 and 1. 0 and 1. 0 and 1. 0 and 1. 1 and 1. Vertically I had to calculate. If both are 1, then result is 1. If both are 1, if any one is a 0, result is 0. And already we have seen logical and. If both are true, then only result is a true. Likewise, bitwise and. Vertically both should be 1. Vertically both should be 1. Vertically both should be 1. Find out what is the decimal value. 17. Program also giving 17 only. bitwise or bitwise and bitwise or bitwise and bitwise or bitwise and. Let us see the third operator, bitwise XOR. You can go for shift 6, cap symbol. Shift 6. Shift 6, it is a XOR. It's called as a XOR. Bitwise or bitwise XOR. Guys, bitwise XOR, bitwise XOR. It's a cap symbol. If both are opposite, then results 1. If both are opposite, then result is a 1 in the XOR. 0, 1, 1. 0, 0, 0. 1 and 0, 1. 0, 0. 0, 1. 1 and 1, 0. 0 and 1, 0 and 1, 0 and 1, then 0, 0. Sorry, 1 and 1. Find out what is the value. XOR. Vertically both are different, opposite. Vertically both are opposite. So what is the value? 686. Let me compile and run. 3 bitwise operators we have seen. OR and XOR. OR and XOR. If you know conversion, then bitwise operators are nothing. If you know conversion, bitwise operators are very simple. Try doing for one more example. Everybody, take two numbers randomly, follow the same procedure, programmatically find out the result, manually check it out whether it is correct or not. Everybody, randomly I took two numbers. They have seen bitwise OR, bitwise AND, bitwise XOR. Everybody take 20 minutes time. I'll give the two numbers. Do the same. I'm not using any built-in operations. Let's go for 192 bitwise OR, 670. Everything do manually. Find out binary representation, then calculate these three. For 255, what is the binary representation? Some ECE people and computer science students, by seeing the number itself, they can tell the binary string format. Through binary string format, they can see easily decimal format. Even if you practice seriously for 10 days, definitely there is a chance of telling without calculation. Let me change a little. All ones means there will be no fun. Yeah. Take this one. This is the binary representation. Yes. Let us see another bitwise operator. Left shift by 1. Left shift by 2. First analyze what is left shift by 1. What is left shift by 2? This is for 288. Okay. Left shift by 1. See, every digit should move the left side. Come on, guys. The current position should move the left. current position should move to the left side. For that purpose, rightmost, add 1 0, left shift by 1, left shift by 1. Every element should move left side 1. So for that purpose, add rightmost 1 0. Yeah. You can see here, 1 is in this location, move to here. Left shift by 1. The current location should move to the left side 1. Current location should move left side 1. Left shift by 1. Left shift by 1. If you go for left shift by 2 locations, add 1 0. Find out what is the decimal value for this. Find out what is the decimal value for this. Left shift by 1. If you really wanted, you can also go for left shift by 3. Every element should move the left side 1 location. Now calculate 576. So calculate and compare with the output. Come on, guys. Binary string format. Now, let us see right shift by 1. 376. Right shift by 1, 2, 3. Right shift by 1. Left side add 1 0 and remove right side 1 0. Left side 0 adding is optional, no matter whether you are adding or not. Only for symmetric purpose I added 0. Right shift by 1 means rightmost whatever is there, remove 1. Rightmost either 0 or 1. Everything is moving right side by 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 1. While moving right side by 1, rightmost will be leaving from the string. Why? Because rightmost always will be with the 2 power 0 only. 2 power minus 1 is the invalid. Something power minus 1 is the invalid. That is why rightmost, while keep moving to the right side, it will be leaving from the string. Only for symmetric purpose, I added left side 0. Left side 0 is not at all required. Only for meaningful purpose, symmetric purpose, I added 0. Right shift by 1. Every element should move to the right side by 1. You can see here 1 is there. Same 1 moving to the right shift. Here 0 is there. Same 0 coming to here. Here is the 1. Coming to the right side by 1. Come on. Every element from the current location moving right side 1 location. Moving right side 1 location. Even this last 0 also moving right side 1 location and leaving from the string. Dropping from the string. In the binary string, rightmost is 2 power 0. Yesterday we have seen. So there is no like a 2 power minus 1. Whenever 2 power 0, 1 moving to the right side, it will be leaving from the string. Dropping from the string. Rightmost, whatever is there, leave that. If you go for 2 power, right shift by 2. Right shift by 3. If there is a right shift by 4, the last one leaving from the string. No matter what is right side, that will be leaving. Come on, guys. 0 or 1. If you wanted symmetry, keep adding left side zeros. While adding left side zeros, there is no meaning. Still, if you want it, only for the meaning purpose. Now calculate this and find out what is the decimal value. These 5 operators are very much important in the bitwise. Still, there are some more. No need of bothering about other. These 5 only very widely using in the bitwise. Bitwise are bitwise and bitwise XOR, left shift and right shift. There is a complement operator also, but not at all using very widely. It's available in the Lara application. You can ignore that. No one is asking. Moreover, lot of confusion for the beginners. In the website, I explained clearly complementary operator, but no one is asking. Don't go through that one. These 5 are highly sufficient. Actually, in the real-time environment, We won't use bitwise operators at all. Bitwise operators only in the device driver applications. Any application which is interacting with the hardware. Our applications are completely interacting with the database. All enterprise applications are interacting with the database. Bitwise operators not using in the real time. It's only for the interviews purpose we are running. In the projects we will not be using. If project is involving hardware interaction, either device driver or machine learning, then bitwise operators required. Java developers developing enterprise applications which are interacting with the database. While interacting with the database, we require a decimal format, not the binary string format. Binary string format is very significant while interacting with the hardware systems. Java application developing with the hardware systems, it's very rare. Only in the machine learning or in the device drivers. So those and all will not be used. That is why no need of using in the real time, but interviewers are asked. That is why we have went through binary conversion, decimal conversion, and bitwise OR, bitwise AND, bitwise XOR, left shift, right shift. These 5 operators fully go through, that is sufficient. This is all about operators. Next topic is a conditional statements, that is if block, if else, switch cases. Those things we will see in the next class.